So the based on first order reaction, the third question which we have, a first order reaction is 20% completed in 20 minutes. So how long will it take for 75% of the reaction to complete? So a first order reaction is 20% completed. Now here the data is given in percentage. 20% is completed, it means 20% is consumed. So if it is percentage, then initial concentration is going to be, being a percentage, we will consider initial concentration as 100 molar. Now we have to, how much is completed? 20%. So 80 is going to be 80, that is a reactant which is left. So it is 20% is completed. So it is going to be 80 molar. In time it is given 20 minutes. We have to calculate the amount of we have to calculate the time required for 75% of the reaction to complete. So here I can say 75% completion will be nothing but the 2 half-life. So if it is possible, try to calculate the half-life of the reaction. So for half-life, again being a first order reaction, we have a formula T half is equal to 0.693 upon K. So to get half-life period, we require to calculate K. So for K, we again have a formula. K is equal to 2.303 upon T log to the base 10 A naught upon AT. It is equal to 2.303 upon T. T is 20 log to the base 10, A naught is 100 upon AT is 0. So on cancellation we will get 2 ones are 2, then it is going to be again 1s are 5s are, and then so we have log to the base 10 1.25, which is equal to nothing but 0.09691. So on multiplication, this gives 1.112 into 10 raised to minus 2. This is the value of K, and being a first order reaction, the K unit is going to be per minute, and here the time is given in minutes, so it is going to be per minute. Okay, after getting a K, next we have to calculate the time required for the 75% of the completion. So 75, as I said, for that we require T half, that is half-life period. So it is 0.693 upon K, which is equal to 0.693 upon 1.112 into 10 raised to minus 2, which is equal to, the T half is equal to, it is 62.15. After getting a half-life period, we have to calculate the time required for the 75% of the completion. So time for 75% is T75 is equal to, we have a relation that it is 2 half-life period. So it is going to be 2 into T half, which is again in minute, 62.15. So it is 62.15 into 2. It is going to be 124.30 minutes. So this is the value for the completion of, or this is the, this much time a reaction will take for the 75% of the reactant to consume, or I can say for the 25% of the reactant to left. Now the next question, a reaction A plus B gives P has a half-life period of 35 minutes. Calculate the time after which only 12.5% of the reactant remains in the reaction vessel. So here again we have a half-life period for the reaction. Half-life period is given as 35 minutes. And in question we have to calculate the time required for the decomposition of the time after which 12.5% of the reactant is left. 12.5, again somewhere we can relate it with the half-life period. Suppose if in the beginning I am taking 100% of the reactant. So after a 1 half-life period it is going to be a 50. After next half-life period, it is going to be a 25% reactant will left. After next half-life period, the amount of reactant left will be 12.5%. So I can say that the time after which the only 12.5% reactant left is nothing but equal to 3 half-life. So here the time required for after which only 12.5% reactant will left will be equal to 3 times of half-life period. So here I can say 3 times of half-life period means 3 into 35. So which is equal to 105 unit is minute. So after 105 minutes, I can say that 12.5% of the reactant will be left in the reaction if the half-life period is 35 minutes. Now the next numerical based on first order reaction, the decomposition of Cl2O7 at 400 Kelvin in a gas phase to chlorine is a first order reaction. So here the Cl2O7 undergoes decomposition. After 55 seconds at 400 Kelvin, the pressure of Cl2O7, that is the pressure of reactant, falls from 0.062 to 0.044. It means this is going to be the initial pressure, I can say, which is falling from this value to this. That is, this is the pressure after time t. Here the time is 55 seconds. Calculate the rate constant, means again we have to calculate K. Then second part of the question is calculate the pressure of Cl2O7 after 100 seconds. Calculate the pressure of Cl2O7 after 100 seconds means pressure after time pressure after time t we have to calculate. That is PT, I can say, at this temperature. Now we have a formula for determining the value of K. For rate constant we have a formula 2.303 upon T log to the base 10 A naught upon AT, where A stand for the concentration. But in the beginning of the chapter only I said that instead of concentration we can use pressure also. So here we have a pressure of a reactant. So I can use a formula, it's instead of A naught upon AT, we can use a formula P naught upon PT. So in this, the first part, P naught is given. P naught is given as 0.062 atmosphere. And PT is 0.044 atmosphere. Time is also given 55 seconds. We have to calculate K. So K is equal to, I can say that it's a 2.303 upon T log to the base 10. Instead of A naught upon AT, instead of A naught concentration, the pressure is given. So we will use the formula P naught upon PT. So it will be 2.303 upon T. T is 55 into log to the base 10 P naught. P naught is 0.062. upon PT, it is 0.044. On cancellation, you will get this is 231, this is 222. So it's a log of 31 upon 32, which is 2.303 upon 55 into log of 31 upon 22. After all calculation, after this dividing and after taking a log, we will get a number 1.4090. This 1.4090 log is given in a numerical, and if the log is given in a numerical, log is given in a formula, and if the log is present in a formula, then in such cases we never calculate anti-log. So anti-log is calculated when we take log by own. So here the log is already given, so you have to continue with the log value only. So after that we are going to multiply all these three. After multiply and division, after that you will get a number 0.14. This after division you will get log of this 31 upon 22 will give you 1.4090. So this is a log of 1.4090, which is equal to 2.303 upon 55, and log of 1.4090 is 0.1489. And after that multiply and divide by 55, you will get a number 6.2 into 10 raised to minus 3. This is the value of K for the first order reaction. For first order reaction, the unit is per time, so time is in seconds, so per second I can say. This is the first part. Now the second part of the question. In second part, we have to calculate the pressure of Cl2O7 after 100 seconds. Means ultimately here I have to calculate PT after 100 seconds. So for PT now the time is changed to 100 second. Initial concentration is going to be same, that is 0.062 only. So again I will use the same formula, K is equal to 2.303 upon T log to the base 10 P naught upon PT. Now in this case we have to calculate PT. So let us consider log to the base 10 P naught upon PT together, which is equal to, it is K into T upon 2.303. So K is already, we just calculated, it's a 6.2. The value of K is going to be same because the same, we are talking about the same reaction. So 6.2 into 10 raised to minus 3 into time is now 100 seconds upon 2.303. So therefore I can say log to the base 10 P naught upon PT. It is equal to, this on calculation will give you 0.2692. That is after division and multiplication everything, you will get a number 0.2692. So, but we have to calculate P naught upon PT. So P naught upon PT, the log is there, so shift log on the right hand side. Sorry, to remove the log, we'll take an anti-log. So on taking anti-log, this log will get cancelled, and here we will have anti-log of 0.2692. Therefore, now the value of P naught, it is 0.062 upon PT, and the antilog of 0.2692, it is 1.858 into, okay, it's a 1.858 only. Then we have to calculate PT. So PT is equal to 0.062 upon 1.858, and finally we will get an answer for this, and it is 0.033 atmosphere. So this is the finally answer for this. So the rate constant is 6.2 into 10 raised to minus 3 per second, and the concentration left, that is pressure left after 100 seconds is going to be 0.0033 atmosphere. This is the pressure of the reactant which is left after 100 seconds. Next is the half-life period of a first order reaction is 30 minutes. Calculate the specific reaction rate of the reaction. Specific reaction rate means we have to calculate the value of K, that is the rate constant, and what fraction of reactant remains after 70 minutes. What fraction is left after 70 minutes we have to calculate. Okay, so the half-life period is given, that is T half. So T half is given as 30 minutes. If T half is given, we can calculate the value of K. It is going to be 0.693 upon T half. That is, I can say 0.693. T half is 30 minutes. So answer is going to be 0.0231. This is the value of K. Being a first order, again the unit will be per time, it is minutes, so K is equal to 0.0231 per minute. After that we have to calculate reaction rate. What fraction of the reactant remains after 30 minutes? So the time is given as 30 minutes. What fraction of the reactant left means what? Fraction means fraction of reactant left, so left amount is 80. The fraction means upon total, so we have to calculate ultimately 80 upon A0 here. So this is the fraction of reactant which is left after 30 minutes. After 70 minutes you have to calculate. So its time is 70 minutes. So for that I require 80 upon A0. So again we will use the same formula. K is equal to 2.303 upon T log to the base 10 A naught upon 80. So log to the base 10 A naught upon 80 will be equal to K into T upon 2.303. So K it is 0.0231. Time, it is 70 upon 2.303. This after all calculation you will get 0.7021. 0.7021, but this is log to the base 10 a naught upon 80. We have to calculate a naught upon 80. So for a naught upon 80, taking anti-log, so it will become a naught upon 80 is equal to anti-log of 0.7021. So we are getting the a naught upon 80. It's an anti-log of 0.7021, which is equal to 5.036. So it's a naught upon 80. So, but we have to calculate the fraction of reactant left, that is 80 upon a naught. So taking a reciprocal, I can say 80 upon a naught will be equal to the reciprocal of this, that is 1 upon 5.036. And so 5.036, 1 upon 5 is 0.2. So 1 upon 5.036 is approximately equal to 0.2 only. That is slightly 1.98 or 99 it will be. So this is approximately equal to 0.2. So this is the fraction of reactant left after 70 minutes.